demonstration, we're going to show how we can automate NetApp block storage services using iWave Storage Automator. Our demo lab is pretty straightforward. We have a single NetApp FAS series array, which is connected to a couple of SAN switches via a fiber connection, and then that is in turn connected to multiple hosts, and the host that we're going to use for this demonstration is an OpenSUSE 12.x server. Before we get started, we need to have some prerequisite information on hand that'll make the setup process go much smoother. On the NetApp side, we need to understand the NetApp array's IP address and port number, whether we're connecting via HTTP or HTTPS, and then we need to have logon credentials that have administrative privileges to the array. We're also going to provide a friendly name, and that friendly name is going to be what iWave Storage Automator uses to address the array. On the SAN side, much the same. We're going to provide a friendly name. We need to understand the switch type, and in this case that's Cisco. Again, need to understand the IP address and the port number that we're connecting to, as well as provide credentials that have administrative privileges to the array. And finally, for the Linux host, again, we need to understand whether the host is connecting via FCP or iSCSI. In this case, obviously, it's FCP. Provide a friendly name, as well as the address and credentials that have administrative privileges on the Linux host. We're going to log on as an administrator to set up our storage assets. So I have created a administrator ID, and we're presented with the iWave Storage Automator Administrator portal, and that's what we're going to use to set up the various assets that are involved in this demonstration. So the first thing we're going to do is come in and set up the storage array, and in this case we're going to click on and select NetApp. We're going to provide it with a friendly name, TCP IP address, port number, logon credentials, and in this case I know that I'm just going to connect via HTTP, not HTTPS, so we'll leave that unchecked. And then I'm going to click on Save, and if you'll notice, the option Validate Connection on Save has been selected, so that means that iWave is going to attempt to go out and verify that we can connect up to the NetApp array, as well as perform introspection on that array. Looks like I typed everything in correctly. You can see that the introspection's been queued. Again, we're going to cover the topic of introspection in a future video, but essentially we're going out and discovering all the different components of that NetApp array. And indeed, introspection is completed correctly. So now I can move on and set up my SAN switches. So in this case, I have a couple of Cisco MDS switches, which we'll creatively call MDS switch 1 and 2. Provide the IP address and credentials. We should again get to the introspection screen. Okay, then we'll add our second switch. And at this point, you may be thinking that this is kind of an involved process, especially if you have lots of switches or lots of arrays to register. So at the end of this demonstration, I'm going to show how you can do all of this in bulk for large environments. Click on Save. Okay, so we can see that the introspection is already completed on the first switch and is being scheduled for the second switch, and while that is underway, I'm going to go over and set up our SUSE Linux host. So we'll call this Lab 1. It's operating system type of Linux. Again, we'll provide credentials and select FCP as the connection protocol. Click on Save, and again, this is going to get introspected as well. Now that we've configured our NetApp array and our switches, as well as our SUSE Linux host, let's go ahead and see an automated block storage service in action. And to do that, we need to switch over to the user portal, which as an administrator I can do by simply coming up to the upper bar and clicking on User, and I'll be presented a user's view of iWave Storage Automator. I'm going to go to the service catalog, and since we set the service up for a Linux host, I'm going to click on Storage Services for Linux. And then I'm going to click on the end-to-end provisioning service. So this service goes out to the NetApp array in a provisioned storage. If the zone set on our switches need to be updated, it updates the zone set, and then it configures the Linux server to use that storage. So I'm going to go ahead and click on this service. Since we've only defined one Linux host, I have one Linux host to choose from. I'm just going to create a single LUN this time, but I can create multiple LUNs. Go ahead and just create one of 2 gigabytes. I can select the file system type, and then I'm going to select a mount point. And we'll select a friendly mount point of Howdy. Click on Preview, and then iWave Storage Automator is going to go out and make sure that everything is in place on the array, on the switches, and on the host to accept this automated storage service. Once the precondition checks are completed, and if I want to see the precondition checks, I can simply click on Preconditions, and it'll show me each and every one of the pre-checks that we did. I will click on Order, and that'll submit the order for processing. Now, while the order's processing, let's go back over to the administrator screen. One of the things that I mentioned earlier in this demonstration was an easier and faster way to import assets. So if you go back over to Assets, if you don't want to enter in all of your arrays and switches and host manually, and if you have a large environment, you probably don't, you can go over to Import. iWave Storage Automator ships with an Excel spreadsheet, and I just happen to have a copy of that Excel spreadsheet here handy. And on each one of the tabs of the spreadsheet, you can specify all the information that we entered in via the GUI on each tab. So here I have a host tab, and as you can see, we have multiple hosts in our lab environments. A vCenter tab in which I've defined vCenters, a Cisco switches tab, a Brocade switch tab, a VNX tab, a Dell Compellent tab, and so on and so on. So basically, all of the arrays, all of the switches, all of the hosts that we support are represented here in the spreadsheet. And if I want to actually go and import from the spreadsheet, I go and select Browse, go to Desktop, go to Spreadsheet and click on Import, and you can see now that I've imported 18 assets. And now if I go back to each one of my categories, like storage arrays for example, you'll see that there's new storage arrays in addition to the NetApp SAN array, and that they're all in some process of being introspected. If I click on Refresh, I can keep updated on their status. Likewise, if I go over to the SAN switches, now you can see that all of the switches in my Brocade fabric have been added. The Cisco switches are still there, and again, if I click on Update, you'll see the introspection status change from processing to completed with the last date of introspection. Ditto with a host. We can see that all of my hosts introspected. Here I have a host that did not introspect correctly. If I drill down on it, I can find out what the error message was and why that host didn't successfully register. Most likely it was switched off. Okay, well, let's go back over to the user view and check and see how our operation's going. And as we can see, our order has been completed. And if I click on it, we'll see that in fact we have provisioned block storage on our NetApp array. But just to show that we actually did provision the storage, let's SSH into that SUSE Linux host, whose address I believe is 2.1.90. Go ahead and log on. Let's go ahead and change directory to /mnt, do an ls, and sure enough we can see that we have a new directory called Howdy, and it is available for use. So that concludes our demonstration of automating the block storage provisioning process on a NetApp array to an OpenSUSE Linux host.